Welcome. My name is Christopher Skack, and today I am excited to show you our latest plugin for our current AWG products. This RF environment plugin has been highly anticipated, and hopefully this video will help you understand the features and benefits of this easy-to-use tool for creating complex environmental scenarios. RF environmental testing, you ask. With other RF signals being transmitted in close proximity to radar signals, it is important to guarantee these signals will not impact accuracies of the radar responses. This is not only true for military applications, but also important for air traffic control and other commercial applications. And not only could the radar signal be impacted, but it could be possible that your comm signals could be impacted by the actual radar signal. You also want to test for communication capability when you have radar signals being transmitted in the same close frequency proximity. As you can see here, there are many applications that could be impacted. Because of these broad uses, previous challenges in doing these tests included having racks of generators to create these unique scenarios. And of course, with all these generators, required many hours of setup time, and then also the requirements of understanding all the specific generators. With this tool that we have today, we have included everything in one simple application, as you will see. With many tests being done by the National Telecommunications and Information Association, the impacts of these interferences have been documented, and engineers need to be able to make sure their systems are not impacted by these multitude of signals being transmitted. Here we can see some of the signal requirements for this testing. As you can see, these specific scenarios can be very broad, and being able to produce these easily has been a major obstacle for many test engineers. Tektronix has put together a specific waveform creation plugin for our current arbitrary waveform generators that satisfies most of these requirements with an easy-to-use tool that's very simple and straightforward for all these test engineers. Here we can see some of the features of this powerful waveform creation plugin that supports many different comm type signals and radar signals. It seamlessly creates digital analog modulation pulsed radar signals or OFDM signals and can add that to an environment plugin. So you have all the flexibility built into one tool, as you'll see here. Now, with the specific types of signals being created, we have other plugins that help create some of these signals. Here we see that the pulse type signal comes with the environment plugin. If you're requiring to do specific radar characteristics, then you need the radar plugin also with the environment plugin. If you're doing any digital modulation comm type signals, then you also need the RF generic plugin as part of this environment plugin. You will also need the RF generic for any analog modulation and the OFDM plugin for your OFDM type signals. The rest of these comm type signals come with the environment tool. You can also capture your own signals and use the user-defined waveform capability that allows you to also use scenarios with these specific captured type signals that can be captured with a spectrum analyzer and then used with the environment plugin. So with this particular tool, you can change the carrier frequency offset on the fly, power level, phase, duration of each emitter, start time for each emitter. Now when I say on the fly, that's in the tool itself. You can't do it while the waveforms are being transmitted. So you can create many scenarios and then transmit them for the specific tests that you want to make. Now what I'd like to do is actually show you a demo of this great environment plugin. Okay, here I'm displaying the AWG70,000 series general front panel, and I'm going to go into the waveform plugins, and here we're looking at the environment plugin. So you can see the environment is under the RF pull down, and we also have radar and RF generic under the RF applications. So we're going to be using the environment. As we mentioned in the presentation, you can have up to 50 scenarios and up to 100 emitters. So what we're looking at here is several different emitters that we've created. Here we've got a radar. If we, the way we create these basically is you create your scenario by creating the specific emitters that you want in that scenario. So if you want a pulse, you select pulse. And you can see here, these are all the different emitter types that are available for you to choose from. As I mentioned before, some of these require plugins in order to configure them. Some of them are canned waveforms that we've captured from real life scenarios. So you have the definition of your particular emitter type. And if we go into, say, radar here, if we select this, then you can go in and configure the specifics of that radar signal. You know, what your PRI is, what your PRF is, everything about that radar signal is created using the radar plugin that's also available. So under digital modulation, you have the digital modulation and RF generic tool that we use to create these. So this one is a QPSK type waveform, and you can see the characteristics of this particular waveform. You can create specific colors so you know which one's which when you're looking at the graphical display of this particular setup. You can set your frequency, or your center frequency. You can change this at any time. This isn't required to be changed in the actual emitter configuration, but these can be changed kind of on the fly, as I mentioned in the presentation. You can also change the power ratio, the phase offset, and then the start time. If you want one particular emitter to start later than another, you can do that. And you can view this in either a spectrum view, so you can see specifically where the frequency, how close they are to each other, and what center frequency is, and what you can get a better view of what these signals will look like. So here we've created a specific scenario, and I'm playing this, I've compiled this. If you go under the compile settings, you have the capability of creating a scenario as a sequence. In many cases, if you're using particularly like radar type signals where you have lots of dead time, you could be creating very, very, very long waveforms, and sometimes it's easier to create these as a sequence rather than one individual waveform. So in those cases, you can just select this, and it will automatically create the sequences or the sequence required for your particular setup. So this makes it very easily. All of these emitters are all running at the same sample rate. Of course, we've only got one clock in the AWG, but all of them are calculated so that using that one sample clock rate, we can accommodate all these particular types of signals. Now, the other thing that's possible is if you have a signal that's very low level, and I'll show you this in a minute, you could actually output a scenario on one channel and a different scenario on another channel, or the same scenario, and then combine them externally, and this would increase your dynamic range for the particular scenario that you're trying to transmit. So here we're playing this signal out. I've already compiled it. What I'm going to do is look at it here. Here we're actually displaying it on a spectrum analyzer. So we're seeing the specific signals that we've created here. And you can see that they all follow the power ratios that we're providing here. So this is a very a great way of showing that we're producing all of these signals from one generator. So we have all of these signals in one generator, and now you can test your particular setup for that particular scenario. So what I'm going to do now is load another configuration here so you can see a little bit different scenario. Just a second here. Okay, here I am displaying a different scenario here. And in this case, we have several digital modulation, analog modulation, a couple of tones, and Wi-Fi. So this one isn't radar in specific nature. And we can see that looking at the spectrum, we have these particular spectrum. And we have one in here that's very low. It's in the minus 60 dB range. And we really can't see it on the spectrum analyzer at this time. So what I'm going to do, right now we're just outputting this one signal out of one channel of the AWG. So what we can do is we can basically put this out of both channels of the AWG, put it through a combiner so that we are using the full 2 DAC range of the 2 DACs in the AWG, so we get a much higher dynamic range capability. So let me go ahead and configure that real quickly here. Second. So now I've configured it using 2 channels of the AWG, where one of them's so we're power splitting the 2 channels, and you can see that now we've pulled up this minus 60 dB down, or 60 dB signal, that we can actually see it using the full dynamic range of the AWG. So this is just another method of getting signals, or being able to view signals that are pretty much buried in the noise of a single DAC system. So this is a great capability that's also available when you're using the environment plugin for these particular types of testing. Okay, here I've created a very complicated scenario with 8 different emitters. And you can see here the 8 different emitters at the different frequencies. Now if I go ahead and run this, we can see that all the 8 emitters are being transmitted, and we can see the details of each one of these. Now, like I said, you can go in here and you can change the power ratio while it's playing. You can get a good visible here. You will have to recompile it, of course, in order to get those power levels set correctly. You can change the offset. You can change the start time so that you can move these around as far as when they start. The duration, and also how you want it to, if you want it to repeat or not. So this really gives you a lot of flexibility. Oh, you can change the carrier frequency also. So this gives you a lot of flexibility when wanting to do these specific environment type applications. And you can download the plugin for this environment plugin from our website. It is available. And you can get a 30-day trial license. So you can try it, see if you like it, and then decide if you want to purchase it or not. So this will work with our AWG70K series products as a direct plug-in. As you see here, I've got a direct plug-in in the box itself. Or you can use it in our Source Express software, which is a software that runs on the PC. It's a free PC software that allows you to connect remotely to the AWGs and do all your waveform creation offline, and then when you're ready to use the instruments, you can then connect to the instruments and send the waveforms or work with it directly offline remotely, so that you can create these scenarios when you need to, and then actually use the equipment when you need to. So I'm hoping this was very useful for you. And again, if you have any questions, please get back to us at Tektronix and try this new plugin out. And I'm sure you'll enjoy being able to create these great scenarios with this very powerful tool. Thank you for your time. Bye now.
Find out more at Vicom's website.